Okay, today we're doing topic 6.4, solving trigonometric equations using our identities, from page 316 of our textbook. We want tonight to solve some trig equations. We'll need to make some substitutions using our trig identities. In our first example, we want to solve by substituting algebraically over the domain 0 is less than or equal to x is less than 2 pi. And our first equation is the cosine of 2x plus 1 minus the cosine of x is equal to 0. Well, the substitute, the cosine of 2x is 2 cos squared x minus 1 plus 1. And if you take away the brackets and simplify it, negative 1 plus 1 will disappear. And you'll be left with 2 cos squared of x minus the cosine of x is equal to 0. Now, we can factor out the cosine, and we'll be left with 2 cosine x minus 1 times cosine. Now, this tells us that these two will give you a product of 0 when the cosine of x is equal to 0, or when 2 cos x minus 1 is equal to 0. Now, the cosine of x is going to be equal to 0 when x is equal to pi over 2, or 3 pi over 2, or 2 cos x is equal to 1, or the cosine of x is equal to a half. Well, that's going to occur when x is pi over 3 or 5 pi over 3. So now what we have is 4. There are no non-permissible values for the original equation, so the solution over the domain 0 is less than or equal to x is less than 2 pi are x could be pi over 2, 3 pi over 2, pi over 3, and 5 pi over 3. That's our solution. For part B, it says 1 minus cos squared of x equals 3 sine of x minus 2. Well, we know 1 minus cos squared of x is sine squared of x. So we'll do that substitution. Now, if you would bring everything over to one side, the sine squared of x minus 3 sine of x plus 2, we can find that we can factor this because it's really a trinomial. We have the sine of x times minus 1 times the sine of x minus 2. If you FOILed it quickly, we'd get our original equation back. Sine squared minus 2x minus another sine of x and plus 2. This tells us then that the sine of x minus 1 will equal 0, or the sine of x minus 2 will equal 0. Well, to ask where the sine of x is equal to 1, that's going to be at pi over 2. To ask where the sine of x is equal to 2, well, that's never. Sine is going to have a value between 0 and 1. It's never going to equal 2. So there's no solution. There are no non-permissible values, and so the solution over the domain 0 is less than or equal to x is less than 2 pi is simply pi over 2. Okay, we have example 2. Solve cos squared x is equal to cotangent x times the sine of x algebraically over the domain x is between 0 and 360 degrees. Then they want to verify this graph, verify it by graphing. Now we have cos squared x is cotangent x times the sine of x. The cotangent of x can be written as cos x over sine of x times the sine of x. So now we have the cosine squared of x equals cosine of x. If you bring everything over to one side, cosine squared of x minus the cos of x has to equal 0. Now if you factor out a cosine of x, you're going to get cos x times cos of x minus 1 is equal to 0. So that tells me that the cosine of x has to equal 0, or the cosine of x minus 1 has to equal 0. Again, the cosine of x equals 0. when x is 90 degrees, 270 degrees. And the cosine of x will equal 1 when x is equal to 0 degrees. When we check for non-permissible values in the original equation, for cotangent of x, the domain has the restriction that sine of x cannot equal 0, or 180. Therefore, our solution is limited to x equals 90 and x equals 270 degrees. Verify graphically. If you look at, we can say y1 is equal to the left side of our equation. y1 is equal to the cosine squared of x. y2 is equal to the right side, so y2 will equal the cotangent of x times the sine of x. And when we have our graph, it's going to look like the following. Notice that they intersect at 90 degrees. Is that right? 90 degrees? Let's see. Yes, 90 degrees. At 180 degrees, they're way farther apart, and then at 270 degrees, they're crossing again. It also looks like they cross at 0, but you remember that that was our non-permissible value. Example 3. Solve sine of 2x equals root 2 cos x algebraically. Okay, this time they're asking us to give the general solution expressed in radians. We can say that the sine of x is root 2 cos x. Oh, pardon me, that should be the sine of 2x. So 2 sine x cos x, we can replace that with, is going to equal root 2 cos x. If I bring everything over to one side, 2 sine x cos x minus root 2 cos x equals 0. I can factor out a cosine of x to get cos x times 2 sine x minus root 2. That tells me that one of my solutions, the cosine of x, has to equal 0. Or 2 sine x minus root 2 has to equal 0. Again, the cosine of x is going to equal 0. Well, let's do the other side first. 2 sine of x equals root 2. Divide both sides by 2. The sine of x is root 2 over 2. So the first one, that's when cosine of x is going to equal 0 when x is pi over 2 plus pi n, where n is any integer. And the sine of x is going to equal root 2 over 2 when x is equal to pi over 4 plus 2n, and when x is equal to 3 pi over 4 plus 2n. There aren't any non-permissible values, so the solution is x equals pi over 2 plus pi n, x equals pi over 4 plus 2 pi n, and x equals 3 pi over 4 plus 2 pi n, where n is any integer. That's my happy face because there's only one more example.